Good day, good people. In this video, we will combine Angular components with an HTML canvas graphics renderer to create an interactive periodic table of elements. We will then hook up the Angular router to our periodic table and use it to navigate backwards and forwards through the elements like so. We will use the metadata from some Adobe Illustrator artwork to drive our canvas graphics rendering from within our Angular component. This data model represents these vector graphics. This data model was extracted from Adobe Illustrator using the Adobe Extended Script Toolkit JavaScript API. So for each element here, for example, the hydrogen element, there will be one object which contains the text frames, the name of the element, and the metadata that represents the vector artwork, the points for the paths. I will be starting out with this template, which you can get from my GitHub page, or you can download the complete code for this tutorial as well, Angular periodic table. So the first thing we're going to do is clear out all the existing components and create one periodic element table component using the Angular CLI. So since I'm running this app from localhost via Visual Studio Code, I'm actually going to type the Angular CLI commands from Commander. So within Commander, we want to drive into the client app source app folder. So we'll cd client app source app. And within this folder, we want to create our Angular component for our periodic table. So ng component periodic table. So now if we come back over to Visual Studio Code, we can see that our periodic table component has been created and that it has been registered within app.module.ts. So to begin with, we will replace these routes with one route for our periodic table component. Then we'll go to our periodic table component.html and add a canvas element. Next, we can go to app.component.html and get rid of everything except for the router outlet. So we'll remove the header as well. And now if we come back over to our app, it should just be a white screen. And if we right click and inspect, we should be able to find our canvas element. App root. There's our canvas element. The canvas element has a graphics API which renders an image but does not have an underlying document object model like HTML. Therefore, to be able to interact with our canvas graphics, we must create a logical display model for our periodic table. Our logical display model will be an array of objects, each of which representing one of our elements. Each object in our logical display list will contain the width and height of each element and the x and y coordinates within the Cartesian area of the canvas. So along with our periodic table component, we will create an element model, which will be the model for the objects in our logical display list. We will create a periodic table model, which is a class that contains the metadata that we got from Adobe Illustrator. And we will create a periodic table model service, which we will use to get an instance of our periodic table model. So I'm going to go ahead and use the Angular CLI to scaffold up those classes for us. Okay, I've used the Angular CLI to scaffold up our service and our two classes. So if we come back over to our app, we can see our element model.ts, our periodic data model.service, and our periodic data model. So next we can go to app.module.ts and register our service. So we'll put the service there, and it also needs to be registered in the providers array. Next we will come to our periodic table model, which is just a class, and we will take the JSON that we extracted from Adobe Illustrator and add it to this class. Okay, now I've added the metadata to our periodic table model, which is just an array of objects. Next, I will come over to our periodic table component and add references for our classes and our service. Since we'll be working with a reference to our canvas element and the Angular router, I need to go ahead and add element ref, after view init, view child, and on destroy to our import statement. We will go ahead and remove on init and implement after view init and on destroy, so we'll get rid of that. And we'll go ahead and use the IntelliSense to go ahead and implement these things. So I'll move ng on destroy to the end of the class. Go ahead and add public. It's public by default, but since we're using TypeScript, it is my preference to denote the access modifiers. And I like to have these guys after the constructor. So we can go ahead and inject our periodic data model service via the constructor. And now we can go into our periodic data model service, go to definition. We can go ahead and import our custom class. And this service will simply have one public method or function that returns an instance of our periodic table model. Now we can go back over to our periodic table component and start adding some code. So the first thing we need is the JSON model for our periodic table. So we'll add a private property, which will simply be an instance of our periodic table model. The next thing we need is an array to hold our logical display list for the periodic table. This is what we use to figure out which element we are interacting with on the screen when we are doing things like mousing over or clicking on elements. We will need a reference to the view child, which is the canvas. So we'll add a view child canvas public canvas element ref, and that will reference our canvas element via this identifier. And we also need to add a reference to the canvas rendering context 2D, which is the API we use to draw graphics on an HTML canvas. So now we can begin implementing code in ng after view init. So the first thing we want to do is set our periodic table model by calling our service. Okay, so we will quickly come back over to the browser and just test that everything is working correctly so far. So I'll refresh the page. And we will come into our periodic table component and hit the breakpoint in ng after view init and call our service and verify that our model is set correctly with our periodic table model and its array of elements. So everything looks good there. Alright, so the next thing we need to be able to do is get a reference to our canvas rendering context 2D. So for that, we're going to add a function to set the canvas rendering context for this component instance. So here we simply use the canvas native element get context 2D to set the context for this instance of this component. Next, we're going to add a function to initialize the canvas width and height based off the width and height of the window. So the canvas is basically going to fill this entire area when the app initializes. After we do that, we want to fill the background with black to make our elements pop off the page. So we will use this.context fill rex to fill this white area with black. So we can come back to ng after view init, call our first three functions. Oh, excuse me, I put them in the constructor. I need to go in ng after view init. Okay, now we'll just go back over to the browser, which should have refreshed itself, and we will step through our code quickly to make sure that we did everything correctly. So we will get our model, set the canvas rendering context 2D. So this context is set. We'll initialize the width and height of the canvas, and then we will fill the background with black. So everything looks good so far. We'll come back over to Visual Studio Code. So the next thing we need to do is populate our element display list. So we want to populate our display list with an array of element models. Each of these models will represent each element in our periodic table. So we basically need to create an instance of an element model for each item in our periodic table models JSON file. So the first thing we can do is come over to our element model.ts and add some instance variables. So at the top here, I'm going to paste some commented out JSON, which represents the model for one element. So each element is going to have a text frames array, and each text frame is going to contain information such as the font, the color, the size, and the X and Y coordinates of the bounding rectangle of the text. This JSON also contains the name of the element, in this case it's helium, and a paths array. And the paths array contains the color of the paths, whether it's a fill or a stroke, and it also contains an array of arrays of points, which each of these points just represents like x1 and y1, x2, y2, x3, y3, etc. And when we think about this in terms of the Canvas graphics API, this is simply move to, line to, move to, line to, move to, line to, and then close path to complete the shape. So for our element model, we will need the width and the height. We will need the X and Y coordinates of the top left point of the rectangle, the bounding rectangle for each element. And via the constructor, we will be adding a element model, which is this JSON I just showed you, and a reference to the Canvas rendering context 2D. So that's enough to come back over to our periodic table component and get started with the function that will populate our display list. So we'll call this function initialize elements, and this will initialize the logical display list for the periodic table. We will get the elements array from the periodic table model, and for each one we will create a new instance of our element model and then call element.drawGraphics and element.drawText, which we will create in a few moments. Essentially I guess I don't need to comment this out, but essentially each instance of each element model will be responsible for drawing its own graphics and drawing its own text, and then removing and re-rendering itself when we mouse over or click on things. So we'll come back over to our element model and stub out our draw text and our draw graphics functions. And now we can come back over to our periodic table component and call initialize elements from within ng after view init. And now we'll come back over to the browser to test our progress. So the browser, our app refreshed itself. We can now go into initialize elements and jump to the end, and we can see that our element display list was populated with instances of our element model. Okay, so now that that's working, we can come back over to our element model.ts and go ahead and start filling out our draw text and draw graphics functions. So before we do that, we're going to add a couple more instance variables, one of which is a property called is within bounds. This property is going to be used so that we know when we hover over a particular element's bounding rectangle. So basically when we hover over and mouse out of some rectangle on the canvas screen, as soon as we're within the bounds, we want our graphics processing to stop and start again once the mouse is out of the bounds. So that's what this flag is for. We will also add a flag called isSelected, which we will use to denote that an element has been clicked on and therefore should remain selected after the mouse leaves the bounding rectangle. We will add an optional scaling factor variable, which we can use to scale up the X and Y values for all of the graphics on the screen if we want to. And last but not least, we will add a flag called isInstantVariableSet, which we only want to set the width and the height and the X and the Y values one time based on the rectangle portion of our element's graphics. And once that's set, we're good to go for the lifetime of the logical display list. Okay, next we can go ahead and fill out our draw graphics function. And just to talk about this for a moment, I will come back over to our Illustrator graphics. And the metadata that represents each element here, what we're looking for the bounding rectangle is the background rectangle there. That's the bounding rectangle of each element. So the draw graphics function, part of it knows to grab the particular object that represents that bounding rectangle and pass it to a function called set instance variable so that we can use that metadata to create this element model's instance bounding rectangle. So we'll go ahead and create the set instance variables function. And this function uses the values from the background rectangle of an element's graphics model to create the logical model for this instance's background rectangle, as I just said a moment ago. So this code knows exactly what part of the array to vector into to grab the appropriate x1 and y1 and x2 and y2 values for the upper left-hand corner of the bounding rectangle and the width and the height of the rectangle. And once this is done, instance variables are set for the lifetime of this instance in memory. When this metadata comes into our drawGraphics function, I know that I want to reverse the paths array because the stack of graphics needs to be reversed so that they render properly on top of each other. So this code is going to clone the paths array and reverse it so that we can continue on with the rest of the function. Once we get into the loop, we grab a path item out of our path items array, get the path items points, get the path items color, and begin the path. Then, for each point, we get the current point. For the first point we move to in the Canvas Graphics API, this is what starts a path. So it moves the renderer to this point to start drawing a line. Once we've gone through this first iteration, everything else is going to be line to. So every time we get a new set of x and y coordinates, we move to and then line to. So that draws all of our graphics. Once we get to this point, we can save the Canvas graphics state so that we can manipulate whatever this graphics fill style is. Once we've done that, we close the path. So these sets of points come in with, in the case of like a hexagon, it draws all the sides except for one, and then close path closes the hexagon and fills in the shape. And looking back at our elements, we have one graphic that is just a stroke. So this code knows that in this particular case, we want to actually stroke the path instead of filling it. And then last but not least, we restore the graphic state. So just to talk about the graphic state of a canvas for just a moment, it is what's known as an immediate mode drawing surface, which means that it works on a stack of graphic states. So at any given time, we're in the default state of the graphics state of the canvas. And if we want to manipulate the color or the stroke or the size of the text or anything like that, we can save the current state, manipulate any of those properties, and then restore the state. So we can do those things in a loop to draw different colors and shapes and sizes and stuff like that. Okay, next we can fill out our draw text function. And this is essentially going to do the same thing. We're going to grab the text frames array from our element model, which is this guy, and iterate over each text frame and do the same, save the canvas state, update the fill, change the text baseline, update the font, and fill the text, and then restore the state for each variation of the text of each element. So for each one of these elements, we have small text, large text, black text, white text. Okay, so now that we have that done, we can again test our initialize elements function. So this function is going to initialize our logical display list and draw the graphics and the text for each element model. So our app refreshed itself. We've now hit a breakpoint in initialize elements, and we will step through it and watch our, hopefully, graphics get drawn. So there's our graphics, there's our text. And let's see if we can do this a little faster. There we go. Okay, we can come back over to Visual Studio Code and start working on the interactivity of the periodic table. So I'm actually going to come back over to the browser and tear out the dev tools. You can see when they're open, it actually rendered only half of the canvas. So I'll refresh the page. And now we have our initially rendered periodic table of elements. So right now there's no interactivity. It's just static stuff. There's no routing or anything. So that's what we're going to work on next. So again, since we're using an HTML canvas, there's no DOM associated with these graphics. If we right-click and inspect, all we see is this individual canvas here. And that is what the logical display list is for. So we're going to use mouse events and the information in our display list to figure out when we're mousing over each one of these elements. So the next thing we need to do is come back over to Visual Studio Code and go to periodictable.html and add some event handlers for a click event and an on mouse move event for our canvas. So next we can come back over to our periodictable.component.ts and add a function which will handle on mouse move for a hover effect and on click for selecting an element. This function will take the page X value and the page Y value of the mouse so we can perform a hit test on the bounding rectangle of an element, and it will also take a navigate flag to determine if we actually clicked so that we can select an element. So next we can add our event handlers for our events we just added to the HTML file. Our on-click handler will have an event object, and within the event object, the page X and page Y value and the navigate flag will be passed into our on-mouse action, and the same for our on-mouse move. Okay, now we can go ahead and finish filling out our on-mouse action. And this code is basically going to perform a hit test within the area of an element to see if the mouse is within the bounds of any particular logical display list items bounding rectangle. So if we are within the bounds of an element, we're going to set the element's is within bounds flag to true, and then use that flag to re-render the element with different colored text so we can simulate a hover effect on each element. I'm just going to go ahead and comment out the stuff we haven't got to yet. So here, every time we want to create a mouse over effect, we want to clear out the graphics and then redraw them. So we need to go back to our element and add our clear function. So we can go back over to the element model.ts and add a function that will simply clear a given rectangle. So to do that, we save the graphic state. We update the fill style to black because sometimes when you clear a rectangle, there's like a little white pixel artifact left over. So this code is just going to clear a rectangle, then fill it back with black, and restore the canvas state. And that wipes out any periodic table element graphics and replaces it with our new graphics. Okay, now let's go ahead and come on back to the browser, and it should have refreshed itself, and we will test our hover action. So when we hover over it, the code should clear out the rectangle and re-render it with a white letter for the symbol of the element. Okay, that seems to be working, but I want the cursor to actually be a hand, so I'll come back over here to our component CSS file and just add this simple CSS. Our app will refresh itself, and now we have a nice hover effect. All right, so the next thing we want to do is we want to be able to click on an element and have that actually set that text to white and remain that way as we continue to move around the periodic table. So to do that, we'll come back over to our component class, and we will add a function called setSelectedElement. And all this is going to do is it's going to iterate over our logical display list, find whatever element may have been selected already, set that back to false, and then set the currently selected element to true. And what that's going to do is down here in our onMouse action function, it's going to let us set this information in our instance of our element so that when our element model re-renders itself, it knows that it was selected and that it can use the white text. So we can go ahead and save all, come back over to our app, which refreshed itself. Now we have our hover action working nicely, and if we click on something, it should select it. So every time I'm clicking on that, that code is running, which sets the selected element, and then re-renders the graphics with the appropriate color. Okay, so this is pretty neat, but what would be even better is if we used client-side routing to actually track where we were clicking and then move back and forth between each element's state with the browser. And Angular's router will be just the thing we need for that. Okay, so we can come back over to our periodic table component and import the router and the activated route from Angular. And what this is going to do, the router is going to allow us to navigate explicitly from this component, and the activated route is going to provide a params observable which we can subscribe to react to changes when the browser's URL changes. So in addition to our periodic data model service, we will add the router and the activated route to our constructor, which will expose them to our component. Next, we are going to add a route subscription, which is of type any, so that we can grab the value from our observable and so that we'll be able to destroy it in ng-on-destroy. So within ng-on-destroy, we will add the call to the subscription to unsubscribe from the observable and release any references this component instance may have on the observable. The next thing we can do is come back to ng after view init and subscribe to our params observable in the activated route. And within the subscription, we're actually going to call a function called onRouteChanged, which we will add here. And every time that function is called, this subscriber will be given the value of the parameter in the URL, and we will call this.onRouteChange with the value of params.id, which is just going to be the name of the element, like helium H, or excuse me, I'm not sure if that's helium. Yeah, helium He or hydrogen H. So these values will actually be what we use in the URL to drive navigating around the periodic table. So within onRouteChanged, all we need to do is use the element ID to look up an element from our logical display list. We will set the selected element with the element we found in the display list, and then we will use the onMouse action to handle everything else by passing in the X and Y values from the element directly. We will shift the X value in by 10 and the Y value down by 10, plus the offset of the top, since we do not need to account for the mouse Y offset when calling onMouse action in this way. And in our case, we actually aren't using any offset, so that's just in case anybody wants to like add a header or something, or add some other graphics around the actual canvas, we need to account for the offset between the edge of the canvas and the window. So as one last piece for this, we need to come to app.module.ts and configure the routes for our periodic table elements. Oh, whoops. Let's see. There we go. All right, so the default route is just by default going to drive to our, make sure I say it right, our helium element, and otherwise it will just inject the periodic table component. Okay, so back in our periodic table component.ts, looking at the onRouteChange function one more time, all we're doing here is taking advantage of the onMouse action by simulating the values that we would normally have gotten by clicking when the route changes. So when the route changes, we're going to look up the element by the element's ID and then simulate a mouse click by offsetting the X and Y values from the element model from the logical display list to simulate selecting one of the elements when the browser's route changes. All right, and we just need to add the ID parameter to this route as well, so ID. All right, so now we can go ahead and the app should be refreshing itself, and we hit a breakpoint and we'll just go ahead and play through. And we can see that it initialized now with a route of /H, which represents hydrogen here. So we can now click through each element, and it is updating the browser's route, and we can use the browser to navigate back through what we just selected. So coming back over to our component, and looking at our on-mouse action function, as we click or navigate around with the browser, on-mouse action gets called, and within this guy we call this.router.navigate using the name of each element to append the name of the element to the browser, and that is what enables us to use this to navigate around. Okay, so this has been an exercise in sort of flexing our creative developer muscles and using Angular components, TypeScript, and HTML Canvas graphics API to create a neat little interactive periodic table. As I mentioned at the beginning of the video, you can get the complete code for this off my GitHub page, healermedia/Angular periodic table. Thank you for watching.